we're going to do a simple investigation to find the molar mass of a compound. We've got lots of elements in compounds. Take something like iron, magnesium. We know the molar mass from the periodic table, but how do we actually work that out? Well, we're going to use a cigarette lighter, which is full of butane, and we're going to do a simple investigation to find the molar mass of that butane. How do we do it? Well, number of moles is mass over molar mass. If we rearrange that, we get molar mass equals mass over number of moles. That makes sense. If I have 20 grams and it's 1 mole, the answer I'll get is 20 grams per mole. That makes sense. If I had 20 grams and I had 2 moles, then it's only 10 grams per mole. So that makes sense. To work out the molar mass, I just need to know the mass and I need to know the number of moles. So how do I find those? That's easy. I just weigh it and I can get the mass. But how do I find the number of moles? Like butane gas, a piece of iron, how do I know how many particles are in there? Well, there's a little trick that makes it possible to do this. It turns out that for gases, 1 mole of a gas at normal temperature and pressure has the same volume no matter what the gas is. 1 mole of any gas is 24.79 litres. And they put that on the data sheet for you. You'll have it in the exams. That's amazing. You would think that if the particles are bigger, then the volume of that gas might be bigger for 1 mole. But it turns out that if you've got the same number of particles, like 1 mole of any gas, the volume is the same. So that allows us to work out the number of moles. If we have a gas and we know the volume, we can work out how many moles we've got. So let's do the investigation. We'll pause the video. So this is how we do the investigation. I've got the cigarette lighter. All I want to do is measure a certain mass of gas from it and the volume of that gas. So how do I do it? Well, I weigh the cigarette lighter first. That's the total mass of the cigarette lighter and the gas that's in it, and I record that. Then I want to take some gas out of it, and I want to know exactly how much gas came out. So a simple way to do it is I've got a container full of water. I put a measuring cup in there, or a measuring cylinder if I had one, and I've turned it upside down, but the cup is full of water. So if I release some gas under there, it will go up into the cup and I'll be able to measure the volume. I'm now going to take my cigarette lighter, I hold it under there and I release the gas. You may not be able to see it on the video, but there are bubbles going up. They're coming out of the cigarette lighter and I'm capturing them in the measuring cup. Now I could do that until I've got 50 mils, 100 mils. The more I do, the more accurate it will be. That's what normally happens with measurements. The bigger the amount you're measuring, the more accurate it is. So I would keep going until I've got quite a lot of gas. It's up to about 10 mils. I'm going to stop because you've got the idea. And now I know exactly how much gas was released. Then what do? I'm going to weigh my cigarette lighter again. Now the problem is it's wet and that will mess it up. So I would dry it as much as I can, shake it, sit it down, leave it to dry, maybe leave it overnight or something. Then measure the weight again. And the difference is the mass of the butane gas. So I've got the mass of the butane gas that I've released. I've got the volume, and I can calculate the molar mass of the butane. So I'm going to give you some data that you can use, sample data from an investigation, the mass and the volume, and I want you to use it to try to work out the molar mass of the butane. And then, if you know that butane only contains carbon and hydrogen, you can probably work out the formula for butane. Let's stop the video.